Good morning everyone. So in today's class we shall start with the topic of congestion control in TCP and other techniques in TCP. Okay. So today's topic is congestion control in TCP. Okay. So why we are getting into this congestion control? Generally, whenever we are transmitting data over the network, it passes through the network and reaches the destination. That is, from source to destination. Okay. So this is a network. So if there is no problem in the network, if router and everything goes works correctly, there is no problem in the network, and the packets will reach from source to destination in a very proper way. Okay. So if there is some traffic problem or there is some network crash in the network, what happens? So at that time the packets get stuck in the network itself, right? So at that time the congestion problem will occur. So this will mainly occur only in the wireless links. Okay. So whenever you take the fiber optics and copper wires, whatever it is, whatever the wide medium, fiber optics and copper wires. Okay. So these are the examples of wide medium, and these do have the less property of congestion, because whatever the data is being transmitted, the exclusive bandwidth is shared only among these wide cables. That is why there is a less chance of congestion in the wide medium, and there is more probability of congestion in the wireless links. Why? Because if at all, if any packet loss occur in this wide medium, immediately the data gets retransmitted by using that network itself. Okay. So but if the packet loss occurs or if there is any bit error, so the packets need to get retransmitted in the wireless medium. So sometimes either it can, that retransmission maybe, it may be loss of a packet or something like, it may be some delay in the network or flip error or bit error. Whatever the case is, the data needs to get retransmitted. So if it is a case of normal retransmission, the data will get transmitted over the network. But if it is a case of congestion in the network, if the sender retransmits the data again and again, what happens? The congestion will get increased and network crash may occur. So in order to reduce this congestion over the network, we do have certain mechanisms called, first one is slow start, and second one is fast retransmit or fast recovery. So these are the two mechanisms in the congestion control of TCP. First one is slow start and second one is fast retransmit or recovery. Okay. So first we shall start with the slow start mechanism. So the name itself indicates. So what is meant by slow start? Start means starting up. Slow means gradually increasing, right? So what happens with the case of slow start mechanism? Assume that you have a sender and you have a receiver. Okay. And this is their timeline. And whenever you are using this congestion, every sender or receiver will have a window. That means how many number of packets need to get transmitted at a particular instance is decided by this window. Okay. For every sender and receiver, there is a window which indicates that how many packets need to get transmitted over the network, right? So initially the congestion window size is 1, and now sender will start transmit 1 packet on successful acknowledgement. That means here it has sent packet number 1, and what is the acknowledgement it needs to get? That is acknowledgement 2. Okay. So on successful acknowledgement, what happens? Window size will get doubled. So what is the double of 1? It is 2. Now the sender will transmit 2 packets, 2 and 3. On successful acknowledgement, it is going to send on successful reception of data, it is going to send the acknowledgement number 4. Okay. So it has reached the fourth acknowledgement. Now what is the window size? Initially it is 1 and it has sent 1 data. After successful acknowledgement it will be 2 and it is going to send 2 packets of data, right? On successful acknowledgement of 2 packets, what it is going to do? 2 into 2, that is 4. That means it needs to send 4 packets of data. Now it will start sending 4 packets of data. That means 4, 5, 6 and 7. Okay. So on successful acknowledgement, it is going to return acknowledgement number 8. So this is the case with respect to the slow start in the initial phase. That means in case of successful transmissions. So if successful transmission is done, the window size is going to get doubled. Okay. So right. So if we take the graph format, some 0, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so assume that now here what happens if I increase the condition window size to every time if it is going to get doubled, what happens means it is going to get drastically increased. That means 8 into 2 16, 16 into 2 32, 32 to 64. That means it is going to get exponentially increased. So if this gets exponentially increased, the number of packets that is sent by the sender at a particular instant is also going to get increased. So there might be a chance that the data will not get transmitted over the network in a very convenient way. So in order to reduce this, what we are doing is, so here we are keeping a thing called threshold. So this threshold indicates that up to which maximum level the data needs to get transmitted in a exponential way. So assume that my threshold is some 8. So till 8 the data will get transmitted in a exponential way, and after that it needs to get increased by 1. That means here we are going to get a linear phase. So now what I have kept, 8 is my threshold. Now the graph will exponentially increase, and from this stage of point of view it is going to get linearly. So this is exponential phase, and from here it will be a linear phase. Okay, so here after getting into the threshold value, this is my threshold. After reaching to the threshold value, the data needs to be transferred in a very linear way. So what is my threshold now? 8. After reaching the condition threshold size to 8, my data needs to be linearly increased. That means next I need to send 9 packets. Next I need to send 10 packets. Okay, so this is the case when successful transmissions are done in a very continuous way. If there is no successful transmission of data, what I need to do, what the network needs to do, right? So if this is the case on successful transmission, on unsuccessful transmissions, on an unsuccessful transmission, what happens is, if at 8 or 9 or 10, if sender doesn't get any acknowledgement even after a timeout period, or even after or if there is some delay in the acknowledgement, right, what it needs to do is, so not in the acknowledgement, so if there is a delay in the network, or the packet loss occur in the network, it indicates that there is congestion in the network. So it is not possible to retransmit the packet in a very continuous way. So it is the main thing that on these unsuccessful transmissions, the congestion window should be reduced to half. Okay, so the congestion window size should be reduced to half. Now what is my congestion window threshold size? 8. Here if I get any unsuccessful transmission, 8 by 2, that is 4. Now my congestion window size should be set to 4. Okay, so this is case on unsuccessful transmissions. So after that, if it is not an unsuccessful transmission, that is only if at all, if it is a case of some packet loss or some delay in the network, it can start with a normal current congestion window right? So this is a concept of threshold slow start mechanism in congestion. So only one thing, on successful transmission of data, the congestion window size will get doubled. That means it is a exponential phase. So whatever we have written here, and on if there is any unsuccessful transmission, that means either packet loss or some delay in the network, the data needs, the window size will get, after reaching to the congestion threshold, the window size will get linearly increased. That is a linear phase. And on unsuccessful transmission, the window size is reduced to half. Okay, so that is the cases of slow start mechanism. So right, next topic is fast retransmit or fast recovery. So by seeing this fast retransmit or recovery topic, here it indicates that if the sender receives the acknowledgements very effectively and continuously, it indicates the sender of two things. One is receiving all the packets in sequence. That means all the packets that are transferred from sender to the receiver are received in transit. And second thing indicates that all the packets are received and something acknowledgement is missed. That means the next, so assume that you have a sender and you have a receiver, okay, and you have sent packet number 1 and packet number 2, and if you are going to get acknowledgement number 3, okay. So meanwhile, whatever the packet is lost and you have sent packet number 3 and packet number 4. Assume that this particular packet is lost and this packet has been transmitted to the receiver very successfully. So what it is the acknowledgement going to get? It is going to send the acknowledgement 3 itself. Why? Because the packet number 3 is not correctly delivered. That means here the packets are received in sequence, and at the same time the acknowledgements are also received by the sender and packets are also received by the receiver. Only thing is the packet is somewhere lost in the network. So by seeing this, the sender assumes that this problem is not due to the congestion. This particular problem is due to the packet loss in the network. So by seeing this, the sender will identify the problem and he will start it will start transmitting the missed packet in a very easy way. That means it is going to retransmit the packet number 3. On successful reception, it is going to send the acknowledgement 5. Why 5? Because already 4 is delivered to the receiver and 5 needs to be that is the next sequence packet in transit. Here, so in this fast recovery or fast retransmit, only case is the sender is going to send the continuous packets and receiver is also going to send the acknowledgements correctly. So only thing that is happening here is all the packets are transmitted and sender is also receiving the continuous acknowledgements. So on continuous acknowledgements, it indicates that the packet loss is not it is not due to congestion, it is due to some packet loss in the network. So that is the missed packet will be retransmitted very quickly by the sender. So that is a mechanism of fast recovery or fast retransmit. So only thing in this is so rather than sending all the packets, it is going to use the concept of selective retransmission, which requires less bandwidth and it improves the efficiency of the protocol also. Right? So these are the two mechanisms in congestion control of TCP. First one is slow start and second one is fast retransmit or recovery. Thank you.